5.2, multiplying and dividing rational expressions. That's kind of a funny word, rational expressions. So where are you going to find out rational expressions? You can kind of look down there where we got an example, number 2, where it's a fraction, and there's stuff on the top, stuff on the bottom. And really what we're going to have to do is see, can we simplify it at all? All right. This is why the first section was all about, do we remember how to factor? Do we remember how to take exponents and simplify them a little bit? All right, so let's first look at a couple of things, right? Groups versus outside of groups, right? So if I had something like x over x plus 1, I want you to always know that when you see stuff with pluses or minuses, think about those being in parentheses, and that is considered a group. So one of the most common mistakes people try to make is trying to cancel out x's, but that's not right. You can't just cancel out the x because you got an x up here, you got an x plus 1 down there. Because imagine if, let's just say that x is equal to 7. So then we got 7 over 7 plus 1, which is 7 over 8, right? That's if I plugged in the 7 here and the 7 here. Is 7 over 8, just imagine if you would have canceled out the x's first. Well, then you would be ending up with 1. 7 over 8 is not 1. Wrong, right? So that's what we got to remember, that things are considered groups and things are considered outside of groups. So let me even give you this. If I had x times x plus 1, and then I had on the bottom x. Now, this x, which doesn't have anything grouped with it, and this x is outside of this group. Therefore, these x's can now cancel and leave me with x plus 1 over 1, the group x plus 1. I want you to think about groups and outside of groups and how those work. Combine that with what we know about factoring, combine it with what we know about exponents, and we have ourselves a pretty potent rational expression. Okay, so here's what we're going to do. We're going to look at rational expressions, and we are going to simplify the top, simplify the bottom, which means sometimes factoring, which just means getting things together, and then we want to see, do things cancel? And what I'm really going to be looking for is groups and see if they cancel with some other groups. All right, so here we go. We got 4x to the 6 on the top. On the bottom, we got 2x minus 6. So this is a big giant group. This is stuff that is not part of a group, right? I mean, so all of this stuff right here, it's just not part of a group. It's all together as one term. So on the bottom, actually on the top, there's nothing I can do. It's still 4x to the 6. On the bottom, is there a greatest common factor in there? Yeah, let's factor it out. 2x minus 3. You guys see that? 2x minus 3, right? Factor that out. Now, you got stuff outside a group. You got stuff outside of a group. This is its own group. So the only way I'm going to be able to cancel anything with this group is if it looks exactly like another group on the top. Okay? Now, since that's not the case, since these 2 and this 4 are both outside of groups because they're not grouped up with anything else, right? Now, things that are being multiplied are different than things that are being added or subtracted. I can reduce that. So that is going to be 2x to the 6 over, well, that 2 is going to go away because that got reduced down to a 2, over x minus 3 as a group. And if you want to, just keep those parentheses to remind you that that is a group. So now, the stuff on top is outside of a group, right? It's no longer connected with pluses or minuses. And this is a group. So the only way I can cancel that on the bottom is if I see that same group on the top. All right. So we're done there. Okay, let's get into this one. Oh, boy, this is factoring on the top. Oh. All right, so here's what we got to do first. I got to come from the top, and I got to think factoring. All right, so one of the techniques I like to use, slide and divide. So I'm going to do this x squared plus 13x minus 30. So I slid the 6 over here. I did that. All right, now I'm going to break this into 2 parentheses. I'm going to get x, 2 things that multiply negative 30, add to 13. How about plus 15x minus 2? Is that right? 13? Yes, that's good. Okay, now I got to bring that 6 back along. So divide by 6. And then we're going to reduce this down, x plus, let's see, we could do 5 halves, and then x minus 1/3. So since they're both fractions, we bring the number back up front, bring the number back up front. And so then we're going to have 2x plus 5, 3x minus 1. So there's the reduced form or the fraction form of that one. So that's going to stay on the top. So I'm going to get that in just a second. Now let's take this one over here. Let me do a little slide and divide here. So I'm going to get x squared minus 23x plus 35. Two things that multiply 35 add to negative 23. Let's see if I can figure that out. Multiply 35, add to negative 23. Boy, that's tough. 35 divided by 5 is 9. All right. Oh, what am I doing 35 for? Wow. Let me stop that right now. Stop it. Stop. Okay. Let's try that again. 6 times 7 is 42. 42. Right? What am I doing with 35? Okay, let's try this again. Two things that multiply to 42 but add to a negative 23. What about negative 21 and negative 2? Yes, that's good. That works right there. Okay, so then what did I slide over? I slid a 6 over, so let's divide by 6. Let's divide by 6. Let's see if we can't reduce this down. X minus, divide the top by 3, the bottom by 3. Divide top by 2, the bottom by 2. Okay, and then again, we got to slide the fraction back over, slide the fraction back over. So we're going to have 2x minus 7 and 3x minus 1. Okay, so this is on the bottom. So let me now restructure this whole thing. It gets a little complicated, doesn't it? 2x plus 5 times 3x minus 1 on the top, right? That was this one. This one is going to be on the bottom. 2x minus 7 over 3x minus 1. All right, now that we have factored the top and factored the bottom, do you see anything that can cancel? Yeah, how about this group, which is exactly the same as this group. So they actually cancel each other out. Now these groups, they have to be exactly the same to cancel. Since they're not the same, they can't cancel, and we are left with 2x plus 5 over 2x minus 7, right? Now, here's what I want us to also think about. Domain, right? What are our domain restrictions? So domain restrictions are what values of x would be inappropriate for this right here. So looking before I crossed off these values here, what would be the problem? Remember that if on a fraction, let's say I did 5 divided by 0, wrong. You can't divide by 0. It's never appropriate to divide by 0. So if this 2x minus 7, 2x minus 7 equals 0, we would end up with a problem. And if 3x minus 1 equals 0, we would end up with a problem. Now, since we essentially canceled this, this is one of that would create a problem. We want to be aware of it. But this one right here, that's going to create the biggest problem right there. Okay, so what we do, we just solve for this. 2x equals 7, x equals 7 halves. So then we would say the domain is all reals except x cannot equal 7 halves, because if it equals 7 halves, we have a problem. So there's our answer. Domain restrictions are can't equal 7.5. All right, so that's what that looks like. Okay, let's do another one. Here we go. X plus 4 on the top. We need to just factor this bottom. I'm going to do another slide and divide technique. So I'm going to go x squared plus 11x minus 12. Two things that multiply to negative 12, add to 11. Ready, go. X plus 12, x minus 1. Good job. Divide by 3 on both of these. That was the number we slid over. So then we reduce this down. X plus 4, x minus 1/3. Anything that's left is a fraction. We're going to slide the bottom back in front. X plus 4, 3x minus 1. Okay, that's what's on the bottom. Let me rewrite this equation. X plus 4 on the top, the group x plus 4 on the top, x plus 4, 3x minus 1. Do you see anything that cancels? Yes, the group x plus 4. So then I'm left with 1 on the top. You got to have a placeholder, 3x minus 1. What is our domain restriction here? Domain restriction, x cannot equal 1/3, right? Set it equal to 0 and solve the bottom. That would give you the equivalent. Now, if we needed to doubly check, X also cannot equal -4 originally, right? So really, there we have two domain restrictions. This is the obvious one. This is the one that's not super obvious. Okay? All right, so there you go. That is what we're going to be looking with. Okay, let's move to the next point. When multiplying, anything on the top is fair game for canceling with anything on the bottom. Literally anything on the top. So let's take a look at this one right here. So I got this group, I got this group, I got this group, and I got this group. Your number one job is to imagine that everything on the top is eligible with anything on the bottom. So here's what I got. I got x minus 2 on that top times, I'm going to just factor this real quick. What if I took a 2 out of it? Then I'm going to get 2x minus 3, okay? On this one, is there anything I can take out? No. So it's just the group 2x minus 3. Is there anything I can do to this? Yes, that is a factorable thing. That's going to be x minus 2, x plus 2. Okay, here we go. What is eligible? Anything on the top, x minus 2 with this x minus 2. 2x minus 3 with that group 2x minus 3. That 2 is outside of the group, that 2 is locked into a group, so they got to stay. So we're going to have a 2 left on the top, we're going to have the group x plus 2 left on the bottom. Perfect. Domain restrictions, x cannot equal -2, right? Cannot equal -2. Okay, so there you go. That's the obvious one. What if they said, what are the non-obvious term ones? Well, we're also got to make sure that, well, x also can't equal 2, and x also can't equal, if I set this one equal to, it's going to be 3/2. Right, so there you go. Anything that's on the bottom is bad, right? But here's the obvious domain restriction with its counterpart. Okay, let's try this one here. All right, always rewrite it in its factored form. X minus 2 group, x minus 3 group. Nothing can be factored. Let's pull a 2 out, and I'm going to get x minus 3 on that top, and I'm going to get x plus 5 on the bottom. Okay? Groups I can cancel. X minus 3 with the x minus 3. That's it. We got it. So 2 times x minus 2, right? Go ahead. And we're not going to multiply them all the way out. We're just going to keep them in their groups in factored form. So that's what it looked like on the bottom. Domain restrictions, the obvious domain restriction, x cannot equal -5, because that would be a problem on the bottom. Okay. Non-obvious, x can also not equal 3, right? So you always want to keep track of that. And then we keep going here. Let's do one more just in case you want the practice. On the top here, let's do this one. That's going to be x plus 4, x minus 4. Remember our factoring. Over this one, two things that multiply to 4, add to -4. That's going to be x minus 2, x minus 2 times, oh, we got this group x minus 2. Over here, two things that multiply to 8, add to 6. It looks like we're going to get x plus 4 and x plus 2. All right, so factoring is super huge to the things that we do right now. All right, what cancels? X minus 4 group with x minus 4 group, x minus 2 group with the x minus 2 group. And that's it, guys. That's it. So on the top, we got x minus 4 as a group. So go ahead and put parentheses if you want to. We got x minus 2 group, and we got an x plus 2 group. Right? What's the domain restrictions? The obvious domain restrictions, x cannot equal 2, and x cannot equal -2. Right? That would cause a problem. That would cause a problem. We don't want it to equal 0 when we do this. Okay, so there you go. That is multiplying. Anything on the top is good with anything on the bottom. Okay, what about if we're dividing? Okay, dividing. It's turning it back into multiplication. So what does that mean to turn it back into multiplication? That means instead of writing divide, let's write multiply, change it to multiply, but then multiply by the reciprocal. Do you remember what the reciprocal is? It means flip this. So we're going to go x to the 5th, y to the 4th, divided by 3xy times, flip it, x cubed y over 1. And now we just ignore this. I don't care about this anymore. What I care about now is this multiplication. Okay, anything on the top is eligible with anything on the bottom, or we can condense first and then. So it doesn't matter how you do it. So here's what I like to do. X cubed is going to become x squared because it's going to take away this x. The y and this y will cancel. Okay, and now we're ready to put everything together on the top. So x to the 5th times x squared, what do we know? We know it's x to the 7th. We could just add it. Y to the 4th on the top, nothing else for the y, so it's y to the 4th, over 3 times 1 is 3, and the rest of them went away. There you go. Any restrictions in the domain? Nope, because there's no variables left, no obvious restrictions in the domain. Now, if we had to say the non-obvious ones, right, then the domain x could not equal 0. That would have caused a problem. X cannot equal, or y cannot equal 0. That would have caused a problem. That's domain restrictions. The non-obvious, the obvious, there is no restrictions once we get it all reduced down. Okay? So we just need to see, do they want it before or after the reduction? All right, here we go. Let's try this one. All right, so up here, I'm just going to rewrite it first. So it's going to be x plus 3 on the top, x squared minus 2x plus 1 on the bottom, times reciprocal, which means flip. Put the x minus 1 on the top, put the x plus 3 on the bottom. Okay, now I'm just going to rewrite it because I know this can factor down. So group x plus 3 on the top. Two things that multiply to 1 and add to a negative 2, that's going to be x minus 1 times group x minus 1 over x plus 3. All right, what cancels? X minus 1, x plus 3, x plus 3. Okay, what do we have left on the top? 1, because everything canceled, you need a placeholder. X minus 1 is hanging out on the bottom. Obvious domain restrictions, x cannot equal 1. Boom, got it. Okay, so division, just turn it into multiplication, and then everything on the top is fair game with anything on the bottom. All right, what are we trying to do here? Woo, solve. Okay, so what we're going to do, we're going to look at this as two separate components. We're going to first see, does this factor down? Does anything cancel? And then we'll tag on all this stuff, and then we'll talk about how do we do that. All right, let's talk about the top. Let me rewrite the top. So this is going to be 4x minus 3 and 4x plus 3 over 4x plus 3. And then we're still equal to negative 6, okay? So let's keep this guy chugging along here. All right, anything that cancels? Well, yeah, that group canceled with that group. Okay, so then we're left with 4x minus 3 is equal to negative 6. Oh, well, let's solve this. Add 3 to both sides. 4x is equal to negative 3. X is equal to negative 3/4. Boom, we are good. Negative 3/4. All right, so that's what it should equal. Is that right? I add 3, negative 3. Yeah, it looks good. Okay, so then what we got to do, we got to just check, can this be used in this? Actually, I usually like to bring it all the way up to the original equation. So what happens if I do 4, and then I put in my new x value, which is negative 3 over 4, plus 3. Well, let's see, this right here would equal negative 3, and then you still got plus 3. Uh-oh, that equals 0. Can the bottom of a fraction ever equal 0? Nope. So x negative 3 over 4 is the actual answer, right, that I wanted, but it doesn't actually work for this equation because it would create a 0 on the bottom. Cannot create a 0 on the bottom, is undefined. So actually we would say does not exist. There actually is no true answer. This is the answer. Theoretically, this is the true answer. All right, let's try it again. You ready? Let's do this right here. All right, I'm going to factor the top. So I'm going to use my slide and divide technique. I'm going to do it off to the side here so you can watch again how I do slide and divide. I love slide and divide. You don't have to do slide and divide, but man, it works so nicely. So slide it. So x squared plus 7x minus 30. All right, two things in negative 30, add to 7. See if we can just change that. So it looks like we're going to go negative 30. So one's got to be negative, one's got to be positive. I'm thinking positive 10 and negative 3. All right, but then remember slide and divide technique. Now you got to come back and divide both of those numbers by 2. If they divide out cleanly, we are good to go. X plus 5, that's great. X minus 3/2, that's not good. So then anything that stays at a fraction, bring the bottom back in front of the x, and now we're going to have its factored form, x plus 5, and you're going to have 2x minus 3. So that's what the top looks like. So let's take that, let's put that in for the top. So here we go, x plus 5, 2x minus 3 over 2x minus 3 equals 10. Do you see anything that cancels? How about the group 2x minus 3 and that group 2x minus 3? So then you're left with x plus 5 equals 10. Subtract 5 from both sides, x equals 5. All right, there's our theoretical answer. Let's make sure that it doesn't cause a problem right here in the bottom. 2 times 5 is 10 minus 3. That would be 7. That's not 0. This is good. We got it. So that's what we're going to be doing. A lot of factoring, a lot of canceling. Sometimes it's going to be super basic. Sometimes we're going to have multiplication, division on there.